So this lesson is about similar right triangles. So we've been working a lot with right triangles, and we're going to continue to do that. We're going to take a little break from all the talk about angles, the 30, 60, 90, and the 45, 45, 90, and work just with similar right triangles. So there's a theorem that you need to know. It doesn't have a name, but it has to do with this picture that I've drawn over here. When you look at this picture, this line right here is called an altitude. Okay, an altitude is a segment that's perpendicular to one side of a triangle and goes through the opposite angle. So we'll do a lot more with that later this year, but this is an altitude, and it's basically just the height of a triangle. So if I took this triangle and I flipped it over like this, you could see that this altitude I drew is just the height. So this is the base and this is the height. But we're not going to draw it like that. We're going to draw it like this. What we're going to do with this triangle here is we're going to find out how long x, y, and z are in this picture. And the theorem that we need to use says that the altitude to the hypotenuse, so the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other. So two triangles that are similar to each other and to the original triangle. To the original triangle. Okay, so what that means is when we have a right triangle here, and then we have an altitude to the hypotenuse, only to the hypotenuse, which is this long side over here, it forms two triangles. Here's a little triangle here and a medium-sized triangle here that are similar to each other, and they're similar to the whole big triangle. So the best way to visualize this is to redraw all these triangles. So we have the big triangle. Okay, we have the medium-sized triangle, and we have the little triangle. Okay, now when we look at all of these, they're not all facing the same way. They're all twisted and turned. So the first thing that you want to do is kind of turn them all the same way. So, okay, so there's that one. So here we go. I've got three triangles now, and I'm going to go ahead and label all of them. So I know that the hypotenuse of the big one is 12. And I know this is the right angle. I know this is x, this is z. So I'm going to go to the medium-sized one. I know that the hypotenuse, let's mark the right angle. So across from the right angle is the hypotenuse. So across from this right angle is this hypotenuse. Well, this one is z. So the base of it here is 10, and the height here is y. Okay, I look at my little bitty triangle, and the right angle is here. So across from the right angle is x. Right here to the left of the right angle, that's 2, and this bottom over here is y. So now what I have, I've got these three right triangles that I know are similar to each other. And that's going to be very important to me to help me find all these side lengths. So when I look at these, I know, and I'll call this will be triangle 1, triangle 2, and triangle 3. Okay, I know that triangle 1 is similar to triangle 2. So whatever the ratio of this side to this side, so the ratio of these two hypotenuses is the same as the ratio to these two bottoms. And I see that they both have a z right here and right here. So for triangle 1, I have 12 compares to z in triangle 2. And then for triangle 1, I have z compares to 10 in triangle 2. So now I have a proportion I can solve. I cross multiply, I get z squared equals 120. To find out what z is, I need to square root 120. Well, I don't know what the square root of 120 is. Right? I know that 120 is 4 times 30. And I can try to break 30 up more into 3 times 10 or 15 times 2, but it's not going to break up any more than that, at least not for taking out perfect squares. So z equals 2 times the square root of 30. So z equals 2 times the square root of 30. This z equals 2 times the square root of 30. All right, so now I can't find x or y using these two because they're different variables, and I need it to kind of work like this. So I'm going to look down at this one that has y, and this one has a y. So here's a y and here's a y. So I know that in this second triangle, y over 2, so that's this side over 2, has to equal, from this triangle, 10 over, from this triangle, y. So I cross multiply and get y squared equals 20. Y equals the square root of 20. And the square root of 20 is 4 times 5. So it's 2 times the square root of 5. Okay, so now I know that all the y's are 2 times the square root of 5. And 2 times the square root of 5. So go to my last ones. I need to find the x's, right? And it's this one and this one have an x in common. So in the big triangle, x matches up to 2 in the little triangle, and that equals 12 in the big triangle over x in the little triangle. So I cross multiply, x squared equals 24. I need to simplify this. This is 4 times 6, right? So I know x equals the square root of 24. So x equals 2 square roots of 6. And that's it. Those are my 3 side links that I needed to find. It's not that long of a process. It's not as hard as you might think it is, but a little bit of practice and you'll be fine with it.